multiplying by a half. So what are we going to do to counteract that? Well, this is kind of like saying right now, if we're multiplying by 1/2, that's kind of like saying it's x over 1/2, like that, right? This is the opposite of this. Instead of multiplying by a half, we divide by a half. Well, if you wanted to simplify this, you could multiply by 2. So what you're doing, I'm going to write it like this, or you could just say 2 times x. So do the opposite. If you're multiplying by a half, multiply by 2. So if I was dividing by 3 here, for example, I'd multiply by 3. Right? Always do the opposite of what's in parentheses. So here's our xy values. Notice your y values have not changed. They have not changed yet. So I'm going to keep those the same. -4, 4, 4, -2, and 2. My x values, I'm going to multiply them guys by 2. So this is going to be -10, -6, -2, 4, and 10. Multiplying these x values by 2. Again, I know that this part is counterintuitive. Just remember, do the opposite of what's in the parentheses. Let's plot these points. -10, -4. -6, +4. -2, +4. 4, -2. And 10, 2. So what happened to this graph? We have taken it and we have stretched it horizontally. Hopefully you can see that. We've actually taken the graph and this has been a horizontal stretch. Right? So I'm going to write that down here. Horizontal stretch. Or think of it as x times 2. Okay? Again, if you need to pause, rewind, please do so. Feel free, go back, all that jazz. Alright, so 7 is, y is the negative f of x. So what are we doing here? We're trying to find negative f of x. Well, f of x is y, isn't it? So if that's the case, don't I need the opposite of y? I need to take my y's and flip them to the opposite values. So my x's have not changed. -5, -3, -1, 2, and 5. My y's are going to be now +4, -4, -4, +2, -2. Think about what we just did. We just made all of our y's negative. Let's plot this and see what happens. -5, 4, -3, -4, -1, -4, 2, 2, 5, -2. Draw your lines. And once you draw those lines, compare that. Compare that with the original. Here's the original. Here's the new guy. Original, new guy. Original, new guy. Think back a few sections. What did we call it when we made our our y values negatives? What did we call it when we did the opposite of y? It kind of looks like this plateau was up here, now it's down here. This little mountaintop was a valley down here, now it's a mountain up here. Does that look familiar? Does it look like it could be an x-axis reflection? Looks like it to me. So if you make your y's negative, do an x-axis reflection. Alright? Okay, over here. Again, if you need to pause, go back, all that jazz. Y is equal to the negative value of x. It's still the opposite of x, right? Since we're doing the opposite, we're still going to do the opposite. Let me write that down here. This is the opposite values of x. Very simple. Your y values have stayed the same. 4, 4, -2, and 2. Your x values are just going to change sign. So now it's +5, +3, +1, -2, and -5. I bet you can probably guess where we're going with this one on the transformation. Let's plot it. So we have +5, -4, +3, 4, +1, 4, -2, -2, and -5, 2. Connect your dots. And what you're left with is a y-axis reflection. Yay! If you make your x's negative, it's a y-axis reflection. That's not news. That's old to us. So now let's get into the big mamma jamma. Number 9. Look at number 9. Take a second and identify everything you've got going on there. How many things do you have happening there? I see 3. I see a negative here. I see a x plus 4 here. And I see a +3 here. So for a moment, let's take that and let's write the transformations down of what's actually happening. The very first thing you do is label whether it's a reflection or not. Now, if you remember, if the negative is outside of f, kind of like it is on this one, we called that an x-axis reflection, right? So always do your reflections first. X-axis reflection. All right, x plus 4. What is this going to do to my graph? Right? Always do the opposite, so it's going to move it left 4. See how you can give directions now? Left 4. +3 is going to move it what? +3 is going to move it up 3. Okay, so here's how I'm going to do this. Always do the reflections first. It goes like this. First, second, third. Second and third can really be done either way because this deals with x values, this deals with y values, so they don't really relate to each other. But this, reflections always come first. Alright? First, always. X-axis reflection. So I'm going to take my points, my original points, which if you don't remember, they're right up here. So my original x value was -5. So I'm going to do it this way. Watch this. It was -5. I'm going to do an x-axis reflection. Right? Now an x-axis reflection reflects what? It reflects the graph across the x-axis. So what is that really changing here? The x-axis reflection is changing my y values. So do this. Put your point. Put your pencil on -5, -4. This is your first point. Okay? Do an x-axis reflection. Then go left 4 and up 3. What's that new point? -9, 7. Do that with all of your points. So my next point was -3, 4. Do an x-axis reflection. Now you're down here. Go left 4 and up 3. So left 4, up 3. That's going to be -7, -1. Okay. -5, -1, or excuse me, -1, 4. I'm jumping ahead of myself. -1, 4, do an x-axis reflection. So now it's down here. Left 4, up 3. Negative 5, negative 1. 2, negative 2. X-axis reflection, so now it's up here. Left 4, up 3. Negative 2, 5. My last point, 5, 2. 5, 2, x-axis reflection. Left 4, up 3. 1, 1. Should have been plotting all of this, but that's okay. Negative 9, 7. Negative 7, negative 1. Negative 5, negative 1. Negative 2, 5. And 1, 1. Here we go. Draw it. Okay. Alright, so first, when you're looking at these, always do the reflections. So I saw it was a reflection, I'm going to do that first. Okay. Now comes the interesting part. 10 is writing the equation. Well, you know you always start out with y equals f of x, right? And then you're modifying that. So if I started with my original, back over here, if I start with this guy, what I like to do is I like to find a point I know I can find for sure, absolutely for sure. So I would probably go with this little trough right here, this valley, negative 2 and 2, or excuse me, 2, negative 2. I know where that point's at. So I'm going to look at this shape and then look at this shape. Oh, excuse me, not that shape, this shape. The first thing I see right off the bat, if you look at those two shapes, this one is backwards. This one has a y-axis reflection. And I can tell you that because over here, it was straight up the mountain, you hit a plateau, then it hit the valley, and then you were finished. Over here, you come to the valley first, then you hit the plateau, and then you're finished. So it's backwards. It's an x-axis, or excuse me, a y-axis reflection. We took it and we flipped it across the y-axis. We flipped this guy like this. Okay? Well, what else happened? This point right here was at 2, negative 2. So here it is, 2, negative 2. There's that point. So I did a y-axis reflection. Bam! Now how did I get from here to here? Well, I went up 2. Right? So the question is, will that work with all my points? That puts me on this one, but what about all of them? So let's go to negative 5, negative 4. That's this point here. So I want the point, it's the starting point, so it's going to be the end point over here, basically. Negative 5, negative 4. Do a y-axis reflection, so it goes right here. Up 2, I'm on my points. So let's go ahead and write the equation for this. The y-axis reflection is negative x, and then up 2. So we're going to go through and do a lot of practice with these, especially in the upcoming days, and I think it'll be good times. Y'all have a good one.